Welcome to our comprehensive course on sustainable agriculture. This course is designed to provide you with in-depth knowledge about sustainable agriculture and, more specifically, the different systems, their principles, and key practices that you can apply to improve your sustainability efficiency and resilience. Let us have a look at the content and structure of this course. As you can see, we have created 8 modules to cover the most important information about sustainable agriculture. In this video, we will talk about the different systems of sustainable agriculture that exist, and we will choose to focus on more in detail. All systems, their main principles and practices, and the key differences among them can be found in Chapter 2 of this course. We advise you to start with Module 1 and familiarize yourself with important keywords and their definitions. In Modules 3 and 4, you can find more information about sustainable soil and water management. From Chapter 5 until 8, we will focus on the role and benefits of agrobiodiversity and practices to protect it, integrated pest management, sustainable livestock, animals and production practices, and organic agriculture. Let's begin by learning more about the challenges of modern agriculture and the problems that have arisen from intensive farming and livestock production. In the past century, especially after the Green Revolution, the agricultural sector has changed dramatically. More and more farmers globally transit from mixed-crop livestock diverse systems to intensified monoculture-type systems, narrowing down the diversity of the crops and varieties cultivated. During the end of the 90s, this transition to cash grain production systems became apparent in regions of India and Africa, where the farmers shifted from more traditional crops to crops like maize, wheat, and rice. Soil is the most essential factor for successful crop production. However, the lack of crop rotation mechanization, excessive tillage, and chemical inputs have led to the degradation of soil. Globally, millions of farmers are being affected by the intensification of problems like soil erosion, salinization, soil compaction, and a decline in soil productivity and health. All these problems negatively impact crop productivity, food security, water pollution, and resource depletion. While the new intensified cultivation systems promise superior yields, they are taking a hit and cannot meet their potential in the long term, meaning that they are not a viable, sustainable solution. But why is it so essential to change the farming methods that we are using? Over the past few years, we have witnessed an increased interest of more and more farmers and nations in general in more sustainable ways of farming, giving rise to a range of sustainable agriculture systems and practices. At this point, it is essential to highlight that when we talk about sustainable agriculture, we should not focus only on the environment and its protection. Additionally, sustainable agriculture is built on 3 main different pillars. 1. The environmental sustainability. 2. The social sustainability. 3. The economic sustainability. Some may also include a 4th pillar, the sustainable research and innovation. The urgency to transit to a more sustainable system of agriculture is also driven by new legislations and policies like the Sustainable Development Goals and the new Common Agricultural Policy. Last but not least, the general public is now more sensitive on these matters, and there is an increased pressure. The numerous available sustainable practices are not new to the farmers and the sector. The challenge all stakeholders involved in the agri-food sector face is to take these traditional sustainable practices and modernize them to fit in the needs of the current agricultural systems that need to ensure food security for a constantly growing population. Nowadays, there are multiple sustainable systems of agriculture. Many of them share many similarities regarding the practices applied or the targeted system, while differences can be found in their main goals. Before going into depth, let's start by defining sustainable agriculture as a term and system. Sustainability as a term in different systems and frameworks is currently one of the most searched terms online on search engines and social media. More and more companies are starting to take measures to become more sustainable and reduce their carbon footprint. The whole idea behind sustainability is to reach our goals and present needs without compromising the future of the following generations to do the same. Sustainability in the agri-food sector. The agri-food sector is key to the survival and prosperity of the human race. The modern food system consists of numerous parts. Some basics are food production, which is the primary sector of agriculture, processing, distribution, and logistics, retail and market, consumption, and food waste reduction and management. Agriculture is responsible for 1/3 of the total global greenhouse gas emissions, while at the same time being the biggest user of water among different sectors and a significant user of energy. As a result, it becomes apparent that starting from the bottom up and making agriculture more sustainable will benefit all stakeholders of the agri-food sector. When we define sustainable agriculture as a system, we must always consider both environmental and socioeconomic sustainability. The two important parameters of sustainability in an agricultural system are resilience and persistence. That means that a system, to be viable and sustainable, should be able to withstand external pressures and stresses, adapt to change, and maintain good performance and productivity over time. Sustainable agriculture encloses a series of practices that will allow a long-term cultivation of the land and stable food production without causing significant and irreversible damage to the ecosystem. This is the biophysical aspect of the sustainable agriculture. It is essential to always take into account the socio-economic aspect, too. In a sustainable agriculture system, the farmer should be capable of obtaining and using inputs and resources indefinitely. At the same time, another key principle is to improve and put into use the collective and individual knowledge of the community and the farmer to optimize the management and use of the limited resources available. Which are the areas of sustainable farming that we must focus on? There are 4 main focus areas of sustainable farming. The first one is the natural resources management. This area includes sustainable water management, soil protection and regeneration, energy management and alternative sources, and sustainable land use management. The second area is crop and animal production management. In this area, the main focuses are maintaining and boosting agrodiversity, selecting resilient crops and animal species, reducing dependence on agrochemicals, using inputs efficiently, and ensuring animal health and good nutrition. The third is emission reduction and carbon footprint, and the last is community development and farmer welfare. Opportunities of adopting sustainable agriculture. As a more labor-intensive system, sustainable agriculture can create 30% more employment opportunities or places and more than 20% less energy use. At the same time, with the increased awareness and sensibility of the consumers, sustainably produced products are usually sold at higher prices. This, in combination with the gradually reduced use of inputs, can lead to the improvement of the farmer's income. While the adoption of a more sustainable system may come at first with some challenges, numerous data are supporting that can help increase yields, helping to ensure global food security. The increased biodiversity creates a system that can more easily be regenerated and has improved resilience. Women have an increased importance in helping the adoption of such systems and practices. If sustainable agriculture has so many benefits, why does not everyone adopt its practices right away? Let's have a look at the most significant deterrent to establishing sustainable agriculture. There are 2 main obstacles to establishing sustainable agriculture. The first one is the lack of knowledge, and the second one is the lack of capital on behalf of the farmers. Establishing sustainable agriculture methods requires thousands of small steps that all together will take the farmer to the next level in 3 to 4 years. However, some farmers cannot wait that long and rely solely on this year's income. For example, when a farmer sees that a dangerous weed has appeared inside the crop and competes heavily with plants, it is much easier to spray immediately with a herbicide to save this year's crop rather than designing a strategy to suppress weeds gradually through sustainable agriculture practices. Governments, institutions, and policymakers are responsible for forming a realistic plan to invest in training, subsidize production, and encourage farmers to embrace sustainable agriculture practices. On the other side, the general public can also reward sustainable agricultural practices by shifting consumer behavior, showing a clear preference for producers that apply sustainable agriculture practices. There are many different systems of sustainable farming, and there is usually confusion about their common goals, practices, or differences. In the following slides, and in Module 2, you will find all the information you need to easily define and distinguish them, and choose the one most suited to your farm and needs. Let's start. While the difference between conventional or industrial agriculture and sustainable agriculture is quite clear to most, there is extensive confusion regarding the definition of the different systems that fall under the umbrella of sustainable agriculture. In this list, you can find the most important and widely applied systems. Please take a few seconds to read them through. It is essential to highlight that all these systems depend on a number of good agricultural practices, and there is no universal recipe that can be applied. All systems should be partially adapted to each case, condition, and needs. What are the biologically integrated farming systems? Integrated farming systems are farming systems that include multiple enterprises or organisms that interact in space and time and have a naturally synergetic function. The role of the farmers in this system is to identify and integrate these key players and boost and support the existing biological relationships within the farm system. The goal is to maximize production, decrease the dependence on external inputs, create a circular system, use biological and cultural practices, and reduce the negative impact of farming practices on the environment. It is one of the most traditionally applied farming systems. However, it is a knowledge-intensive system. Since biologically integrated farming systems have a holistic philosophy, the farmer should have a good knowledge of the interactions between the components of the system and best combine them at the right time and level. A simple example of such a system is the combination of crop cultivation and livestock farming, and the use of natural enemies for crop pest control. There is no universal rule or recipe to be applied by all farmers. Each farm should be considered separately. The main three principles of the system are to maintain and accomplish high yields production, have a holistic approach, and create a circular, closed production system that takes advantage of the synergies and the waste of the different components of the system, more self-sufficient and resilient system. One example of circular production is animal manure. Instead of removing animal wastes from the farm, farmers can use them as fertilizers in various crops. Last but not least, to reduce the use of external input and the environmental footprint of the farming activity. Which are the main practices applied in the system? The most important are the crop rotation, mixed cropping, cover crops, animal husbandry, rotational grazing, waste management, energy management and use of renewable resources, integrated pest and disease management, nutrient and water management, minimum tillage and soil disturbance, more intensive crop monitoring. A lot of on-farm experimentation should be applied for the successful adoption of the system and the introduction of every new element. The farmer is advised to use new technologies like decision support systems, applications, and techniques, and to consult professional extensions and agronomists. Now let's explore another popular sustainable system: conservation agriculture. While many farmers were already applying practices of this system, the term conservation agriculture was established in the 1990s to early 2000s. Based on 2016 data, conservation agriculture is practiced in more than 180 million hectares, equal to 12% of the global cropland. Conservation agriculture aims to produce high crop yields while protecting, maintaining good soil health and fertility, improving water conservation, and enhancing the efficiency of inputs. The system is highly promoted to be further adopted by smallholder farmers in developing countries. However, to ensure its efficiency and make it economically viable for the smallholder farmers of these regions, its adoption must be combined with some adjustments and supportive measures. Conservation agriculture is a farming system that has three core principles. The first one is the minimal mechanical soil disturbance, in which zero or reduced tillage is applied to help minimize land degradation, facilitate carbon sequestration and regeneration, and reduce greenhouse emissions. This practice is at the core of conservation agriculture, up to the point that the system and the practice are treated as synonyms. The second one is the permanent soil cover. This can be applied by using a growing crop, cover crops, and/or a mulch of organic plant residues. The third and the last one is the diversification of crop species. By increasing agrobiodiversity, the system becomes more resilient. This can be achieved with practices like crop rotation and polyculture. Some common practices of conservation agriculture are zero or reduced tillage or no-till farming, no burning of crop residues, direct planting seeding, integrated pest and disease management, use of cover crops, crop rotation, mixed cropping or polyculture, and agroforestry. Precision and efficiency are at the core of conservation agriculture. Farmers should be aware of the crop needs and environmental conditions to choose the best time for applying operations like seeding and inputs like fertilization. This knowledge, in combination with the use of precision smart farming technologies, can increase the efficiency of the applications and reduce the amounts needed and the losses. More sustainable farming systems are presented in Module 2, as well as the key differences among them all. You can continue studying the material of the course to obtain a detailed overview of sustainable agriculture and how to implement key practices in your farm. Do not forget to take the test and obtain your certificate to demonstrate your new knowledge and accomplishments.